So on Friday we talked about approximating a definite integral, or the area underneath a curve, using left-hand and right-hand Riemann sums, midpoint, and trapezoidal approximations. And so with number 28, which is here, I'm going to demonstrate using a left-hand and right-hand Riemann sum. The instructions say to use upper and lower sums, but as we talked about, I just want you to find left hand and right hand when you see those instructions. So I went ahead and copied over number 28 onto my scratch paper here. And we're going to start with a left-hand Riemann sum. So a left-hand Riemann sum are the rectangles that are formed when we use the left-hand endpoint of each subinterval. So the first rectangle we're going to be looking at, when I'm looking at this first subinterval here, is what rectangle is formed using the left point, or x equals 0. And so I'm going to be calculating the area of that rectangle. The area of a rectangle is base times height, so when I calculate the base, the distance here from 0 to 1/4, is, well, 1/4. And the height is our y value. Y is square root x plus 2. And so my height is x is 0 plugged into y. So when I plug in x equals 0 into y here, I get square root of 0, which is 0, plus 2, which is 2. And then I'm going to do that for each subinterval. So the next left-hand Riemann sum is here. This is using our left-hand point of 1/4. And now I'm going to be calculating that area. And again, my base is going to be the distance from 1/4 to 1/2, which is 1/4. And the height is my y value. Well, my y value now is found with x equals 1/4. When I take that 1/4 and put it into y equals. Well, the square root of 1/4 is 1/2 plus 2, which is 5/2. Okay, and we're going to just keep doing that for each of these subintervals. We're going to form our left-hand Riemann sum and calculate that area. Base will continue to be 1/4 because the instructions say that the subintervals are of equal width, so our base is going to continue to be 1/4. But my height is going to change each time as I use a new x value, whatever the left-hand x is of that subinterval. So now our left-hand x is 1/2. And so I'm going to put in square root of 1/2 plus 2, which is what y equals, square root of x plus 2. So then we've got the next subinterval, so still base of 1/4, but now my left-hand x is 3/4, so I have square root 3/4 plus 2. That's this rectangle. And then 1/4, which is still my base. My height is now going to use left-hand 1. So square root of 1 is 1 plus 2, which we know is 3. Plus, that's this rectangle. Our next left-hand, now our left-hand point is going to be using 5/4. So 1/4 is still our base. That's the distance from 5/4 to 3/2. And then our height is going to be the square root of 5/4 plus 2. Okay, we have 2 more to go because we have 1, 2, 3, 4, 5, 6 subintervals so far. We know we started with 8. And so we have 1/4. Plug in 3/2 now because that's my left-hand x value, 3/2 of that subinterval. And then last one, we have 1/4. And then our left-hand x is going to be 7/4. And so we plug in the square root of 7/4 plus 2. And again, for our height, we are using our y equals. So I'm plugging in whatever my left-hand x is into my y equals to get my height. And then from there, you would take all of that and you would simplify it up. For today, I'm going to go ahead and use my calculator. So go ahead and take a moment and plug it in yourself, just to get that extra practice. And I get the answer 5.684, which is truncated at 3 decimal places. And we know from our approximation here, because we can see that our rectangle doesn't quite meet the graph, that this is going to be an under approximation. And then I will be back with the right hand.